community. Some people do not believe in vaccines. Some people do not believe that humans were on the moon, and some people are not were not believing that density functional theory adequately represent the natural phenomenon. But in order to help density functional theory to enter into the community, the designers of the theory formulated a couple of theorems, almost same level as one does in calculus and partial differential equations. So theorems that prove the density functional theory is correct. So it is, there are exact mathematical proofs. In our chapter, we already covered background in definitions, and now we need to spend 2 lectures on 2 theorems. Okay. This is once again summary from previous lecture. By summarizing densities over little cubes here and there across the universe, we can get total energy. And here are the better writing. And here is the summary of definitions that we covered together 2 lectures before. And I believe we spent about half an hour on these 2 equations. So if you do have set of orbitals, occupied or molecular orbitals, if one multiplies orbital by itself and integrates over space, one is getting 1 from one orbital. Then one is getting 1 from another orbital. And then if one adds together such combinations, one will get integration, one will get total number of electrons. But if one does not perform the integration, then this adding together of all occupied orbitals can be treated as density of electrons. So in average, how many electrons are located in the certain vicinity of space. And it's a function. So one more of the definitions. Here is the electronic part of the total energy. So we temporarily forget about ions and speak only about electrons. And total energy of electrons is composed of kinetic, attraction to nucleus, and electron repulsion. So there is a little crazy notation for in the community of density functional theory. So the definition of this portion of electron to nuclear attraction, one can just make a summation over all ions, capital I, and all electrons, and then put the Coulomb attraction, uppercase R, lowercase r. But in the community of density functional theory, this term is mathematical expression is referred by a term external potential. If we organize a kingdom of electrons or democracy of electrons, then any ions coming to this country will be foreign. So it is some external perturbation that affects electrons. I think the logic is this way. Okay. So there will be a theorem that I'm not sure that there is a slide on it, but that if one does know the density of electrons for a given molecule, then one can reconstruct everything, including the external potential. So if you know the density, you can recognize which ions are responsible for which model creates this density. So we need to prove that if there is a known, if one knows density of electrons in a molecule, one can reconstruct external potential, which means reconstruct potential of attracting of these electrons to the ions. And as a consequence, one can also find the total energy. In our previous lecture, we proved that if there are no ions, if the whole universe is composed of electrons only, we can go from density to total energy, right? By getting that total energy is integral of density to whatever 5/3, right? Over volume. So, but it is only one particular case in absence of ions. Now we want to state that even if there were ions, and by some magic we already found how the density of electrons is distributed in space, it is sufficient to reconstruct where the ions were and what are the total energy, so that we can practice the same trick even for a system with ions. Does it make sense? Okay. So, and here is the copy from textbook. Ground state electron probability density determines the external potential, and therefore also total energy. But I'm getting tired reading this long definition. I think this arrows are better. Other questions about theorem itself, or it is more or less okay? Okay or not okay?
For me, I understand now, but I'm thinking how to get this.
Okay. I'm intentionally delaying our discussion actual theorem, first because I'm not as well prepared, and second because I want all of us to be on the same page and understand next step before we go to practical.
No, that way even I don't understand yet, but I will remember everything you talk about later because I'm thinking about it really deep now.
Okay. So in the proof of this theorem, we will assume that this step is not possible. And out of this wrong statement, we will derive something very non-logical. So if absence of this step gives something non-logical, it will immediately mean that original decline of the correct statement was not justified. And now I'm in, maybe there is no reason for me to do it, but I'm just asking to play a little bit and find synonyms, find words that are equivalent to absence of logic. Or some Boston?
Yeah, okay. For the method, I have a guess is the name of it. It doesn't fit your squares, but it sounds like to me proof by contradiction.
Yes, Proof by contradiction, good. By contradiction, yes, absolutely correct. And there, you answered correctly in a full extent. But let's contradiction. Contradiction. And let's find additional synonym in the language. So contradiction, non-logical, wrong, stupid. Let me open one letter and give thesaurus words which are synonyms to the word that I'm going to bring in. So it should start with A and end with D. Anyone wants to suggest a letter? So something idiotic, ridiculous, starts with A and ends with D. Please just try some letter, and I'll tell if it fits here. You can just start giving letters from alphabet. Maybe you will win.
Maybe absurd.
Yes. So Sarah is getting +3. Yes. Thank you. It in all years there were no game when students guess the word letter by letter. Any year someone gets the whole word right away. Yeah, thank you. And Boston is also getting credit for suggesting by contradiction. Okay, so we will prove this first Cohen theorem by absurd, or in Latin ad absurdum, which is like basically by contradiction. So before we start getting to the proof, here I want to bring a picture, and I'm very proud that I found I composed it through open images from online. I think it is more useful and stronger than actual proof. So what do you see on this picture?
Fingerprint.
And who is on the right?
It's a man.
Is it good man or bad man?
It seems bad man.
Okay, so like a criminal.
Yeah.
So, and in police investigations, criminals are recognized by their fingerprints, right? So, by looking at a fingerprint, one can recognize who was the source of this fingerprint. So, same is with density function theory. The molecule, of course, is very complicated, and it is as complicated as a human. And density is quite a simple concept. But as a fingerprint, it is sufficient to identify who left this fingerprint. So as a criminal investigators, by looking on fingerprints, we can recognize the person, or by looking on the density, we can recognize external potential and recognize all properties of a molecule. Make sense? Okay. And of course, Kohn and his collaborator Honberg were not drawing this picture. They were proving it more mathematically. But I think we are on the same page and get the general idea, right? Yes? No? Thank you. Thank you. So Here is the flowchart that I will go to populate. And in one of the previous years, I was asking class attendees to fill it. I think, I'm not sure if it is a good idea. Maybe not, I'll think over, but we'll cover it in the class. It will be only a memory test. But let's try to populate it and make it as Boston suggested by contradiction. So we'll make a statement statements that will be contradictory. And here I'm opening it slightly from the beginning and from the end. So the theorem tells that if we know the density, we will reconstruct external potential and then total energy. And we will so we will assume that from the same density, one can find two different total energies, which are not equal. So a statement that contradicts the original formulation of the theorem. So we'll assume that from one density, one can get two total energies. And then by some manipulations, we will get a statement that is logically wrong. Basically, what we will get a plus b is bigger than b plus a. So logically, one should put equality sign, and we will arrive to this through some mathematical statement that it should be inequality sign, which is contradicts the healthy logic and healthy math. So we'll start from assumption that from one density one can get two energies and two total energies, and we will arrive to a mathematically wrong statement. I'm done once again. So basically, it is the theorem, and the rest are little technical details. So, what are those technical details? So we will assume that there are two threads, so that from one density one can get two different. Go to highlight mode. Two different external potentials, and then two total energies. And for our technical tool to perform the proof, for our methodology, we will use variational principle. That if one already knows the absolutely correct ground state wave function and absolutely correct minimal total energy of the ground state, then any variation of the wave function will increase the energy, right? So it is the variational theorem that we before we did use it in Hartree-Fock theory. Now we are going to use this variational theorem as a tool to find the contradiction based on the wrong hypothesis that from one density one can get two energies.
Dr. Kirin?
Yes?
What's the significance of the two energies? Why do we have two energies?
Yeah, thank you all. So the theorem tells that from one density, one gets one total energy. Because for in our practical assignments, for each molecule, we were finding one total energy, right? We never put that there are two. And if even if we repeat calculation for the same model, we get the same total energy. And here there is a wrong statement. We know it's predominantly wrong, but we are going to prove with logic that it is wrong. That from one density, one can get two different total energies.
Okay.
Okay. And style of thinking of the people who design and prove the theorem is not practical. If we do research, applied research, our mind are oriented more to practical thinking, and this way, this style of thinking that is offered here is a little bit unusual. So do not be surprised. It's unusual for myself as well. Okay. So from now on, I come unprepared, and I will try to read my own slides and remember what I was reading and composing before. So we need to make connection between densities, external potentials, and the language of variational theorem. So if we have minimal wave function A, Hamiltonian A, and total energy A, then by increasing wave function by some small increment, and this incremented wave function by psi b, we will get some energy that is bigger than our original energy. So I'm going to try to practice the same logic and bring it to the language of the density. Okay. So this statement is the same as I was trying to discuss on the 2 slides ago. I skipped a couple of slides. So here I brought a statement and no one was objecting, which means it was correct. Or let me ask if it seems logical. So here I'm trying just to reproduce variational theorem. By incrementing wave function, I'm getting energy which is bigger than minimal energy. Please confirm. No one wants to object. Okay. Now I'm reproducing the same equation. You see here is the wave function b, which is incremented compared to ideal wave function a. And here I'm performing trivial mathematical operation. I'm subtracting and adding together a Hamiltonian with subscript b. So generally, without discussion what is HB, such operation is permitted, right? Anywhere I can add and subtract the same value. So I even can penetrate inside a correct mathematical statement, add and subtract the same value. And then my practice of the variational theorem can be formulated in the following way. So absolutely correct total energy is smaller than Bryant ket of subtraction of HA and HB where HA is the Hamiltonian of my molecule. Psi B is a corrupted wave function, which is not ideal, which has some increment. And here is an additional term, which has HB with wave functions psi B. So I didn't violate logic by here, right? So I just recast variational theorem and then added and subtracted a term. Please ask a question or protest if something looks wrong, or if you disagree or just not clear about things. Yes, or not sure, or no, or not sure. Yes, one yes.
Not sure.
Okay, but are you? Yeah, thank you. I'm happy that you are showing it because it gives me feedback. So are we okay with the first line on this first equation on this slide?
Yes.
Okay. Now we do have bra and cat notations, right? And we can open. So we have bracket, and then 3 terms inside. I can perform this bra and cat expectation value procedure for each term, or combining 3 terms, or combining 2 and 1 of them. So here I'm taking this first 2 operators and bra and cat vectors. So I'm just performing a combination of this H sub A minus H sub B and this psi B bra and psi B cat. It's possible to do, right?
Yes.
Okay. Now there is a remaining term, H sub B. It was also inside the brackets of this expectation value. So I move this H sub B as it will be standalone term with plus sign. And since we originally started from bra and cat, I also move this bra and cat vectors to keep this procedure of expectation value. Is it okay now?
Yes.
Okay. So we do have on the left, we have inequality. On the left, there is a minimal energy, E sub A. And on the right side, we have 2 terms. One is subtraction of our ideal Hamiltonian HA minus some crazy HB. And on the very far right, we have matrix element of this crazy H sub B taken in the as a sandwich with bra and cat of this updated wave function psi B. So now I do have freedom in this mathematical manipulations to select H sub B anything I like. Because anyway, we add and subtract it. So I select H sub B to be such operator which will be for which psi sub B will be an eigenstate. So it is a logical manipulation. So it is correct, but it's an example of non-practical style of thinking. We just select such h sub b that it will satisfy this equation. And all these manipulations are set up in order to arrive to contradictory statement. So by freedom of choice, one can select such h sub b that it will satisfy this Schrodinger equation. Okay? Or no? Or not clear? So here I just practice freedom. This is choice by freedom. And if we selected this h sub b such that it will be eigenoperator and corresponding to psi sub b, then we can replace this bra and ket notation to the energy E sub b, right? If this is not clear, so h b times psi b. I can just add bra and ket here equals E times b. And I can multiply it by bra from left, psi b. And here, since it is energy, not an operator, I can put another bra psi sub b inside here. I can write it once again. E sub b bra of, sorry for my calligraphy, psi b ket psi b. And by orthogonality relation, this will be equal 1 and cancel. Therefore, we arrive to E sub b, right? Okay. At least I was able to understand and even explain this of my previous slides. And it is the same, just with a little better calligraphy. So E sub A less than this matrix element of subtraction plus E sub B. Now, I'll tell them what is the next step, and then we'll check my slides. We did a wrong assumption that from one density we get two energies. And we labeled them by A and B. But who told us that we should start from A? Maybe we should start from B. So logic will be not violated if we write the same style equations, but we start not from A, but from B. So if we replace A into B everywhere, and we replace B everywhere to A. If from density we get two minimal energies, two eigenenergies, then it doesn't matter which one is the first. And this again is a type of non-practical logic that people who prove theorems are practicing. Okay. Difference between two Hamiltonians is determined by external potentials because kinetic energies and electron-electron interactions are the same. So if Hamiltonian A and Hamiltonian B correspond to kinetic electron-electron, and the only non-equal terms are external potentials. So if we subtract, then this will cancel. And now our inequality arrives to the following one. Minimal energy for the branch A is smaller than expectation value of difference of external potentials plus energy of the branch B. So I appreciate your patience. It is not as much left as we already covered. And I understand very much if your brain start boiling. It's not because large amount of material, it is because it's very orthogonal to standard logic that we use for solving practical problems, even with math and calculus. Okay. So a little bit of notations. If we depart from notations and logic of wave functions, we can notice that external potentials are not quite operators, they are just diagonal functions. And we can express this subtraction of expectation value of subtraction of external potentials as instead of bra, we can write a wave function with star. Instead of cat, we can write wave function without star. And instead of sandwich structure, we just do integration over the whole space. And then in the brackets, there is a subtraction of external potential. A little next step, such product of wave functions can be converted into density. So instead of, we will keep the same inequality, but we will cast it not in the language of wave functions as we typically did for variational theorem, but we will cast it using this language of density. So we'll multiply density times subtraction of potential. Okay. Let me quickly remove all marks. No, it is not possible. They're filled in stone. So the last equation that we just discussed was that energy of the branch A is smaller than this expectation value of the subtraction of external potentials in terms of density plus energy of branch B. So one may want to write down this expression once and then practice it once again by replacing A to B and B to A everywhere. Can I? Let me try if I can erase something because otherwise it is too, yes. It's too busy. So here are these two expressions for branch A and branch B. So expression for branch A and expression for branch B. And they are different by replacing A to B and B to A in each term. So please confirm if you see any logical flaws in this two inequalities. Yes or no? Do not hesitate to tell if more comments are needed. Okay, thank you. So, and we are almost done. Thank you for investing time and your questions. Now, let's focus on the density. We call it row B and row A, right? Because we derive them from bra and cat wave function A and B with and without star. But by the original conditions of the theorem, there is only one density, and we were not trying to violate it. Right? Therefore, we are replacing this row A and row B by simple row without any indices. It is the one density from which we started the theorem. Okay? And now there is only one operation left. I'm going to replace row A and row B into simple row, and then subtract inequality A minus inequality B. Again, there are no logical flaws. No one can forbid me to do this trivial operation. Subtract two equations from each other. And if I carefully practice it, then you see the terms in the middle, as soon as we replace row A and row B to the same row, they will become the same but with the opposite sign. So by subtracting them from each other, they will cancel. So we will subtract row A and row A. Sorry, I did lie. I did lie. We do not subtract. We add them together. It's critical. Phew, sorry. So here you see rows V sub A. Here you see minus V sub A. They cancel. Here we have minus V sub B. Here we have plus V sub B. If we add together, they cancel. And as a result, we are getting E sub A plus E sub B is smaller than E sub B plus E sub A, which contradicts, which is absurd, which is like stupid result. Which and from this we can make a conclusion that an original assumption that from one density one can get two energies is wrong. I'm not inviting you to design theorems and prove theorems yourself each day. Just by getting acquainted to this theorem, we should get a strong argument to anyone who may oppose your future results computed with DFT. So if someone comes against you, you can bring this theorem and tell, everything is proved. My results are correct. Okay, subtracting, getting false result. Therefore, knowledge of total density for ground state determines only one branch of observables: external potential, total energy, and as soon as we know the fingerprint, we know who left this fingerprint, right? So by now you are acquainted of the first Kohn-Berg-Kohn theorem. Meeting is done. If you need to, sorry for taking 17 minutes of your precious time. Anyone is welcome to disconnect. I'll stay here just in case there will be additional questions. But meeting is done, and if you are disconnecting, just looking forward to see you tomorrow on the web.
Have a good night, everybody.
Good night, Boston.
Dr. Kellen?
Yes.